is exactly 180 degree, that is 10 Newton force is acting like this way and 8 Newton force is acting like this way, then the resultant would be minimum and its value would be 2 Newton. Let us solve some other example. Now, the data is given as find magnitude and magnitude of two forces such that if they act at right angles, their resultant is under root 40 kilonewton, but when they act at 60 degree, their resultant is under root 52 kilonewton. Now, let us take this force. On analyzing the data given, you have to find the magnitude of two forces such that when they act at right angles, that is when the angle between these two forces is 90 degree, the resultant would be equal to under root 40 kilonewton, but when they act at 60 degree, the resultant is under root 50 kilonewton. So we are having the two cases here. Let us say the two forces are P and Q. We have to find the value of P and Q. Now when they are acting at right angle to each other, that is P is like this way and Q is like this way, that means theta is equals to 90 degree. The resultant R is equals to under root 40 kilonewton. Similarly, this would be the second case in which P force and Q force, same forces, but they would be acting at 60 degree. In that case, we have to find value of P and Q. Theta is equals to 60 degree and R is equals to under root of 52 kilonewton. Now, looking to the first case, we are having the equation of resultant, that is R is equals to under root of P square plus Q square plus 2PQ cos theta. On squaring both the sides, we will have R square is equals to P square plus Q square plus 2PQ cos theta. For the first case, we are having R is equals to under root 40 kilonewton. So R square will be equal to 40 and that will be equal to P square plus Q square into plus 2PQ cos theta, cos 90, right? So plus 2PQ cos 90, but as cos 90 is equals to 0, this equation would be 40 is equals to P square plus Q square. Let us say this is equation number 1. Similarly, applying the same equation in the second case, we are having R is equals to under root of P square plus Q square plus 2PQ cos theta. In that case, squaring on both the sides, we are having R square is equals to P square plus Q square plus 2PQ cos theta. Now, when theta is equals to 60 degree, R is equals to under root of 52 kilonewton. So, on substituting the value, R is equals to R square will be equal to 52. That would be equal to P square plus Q square plus 2PQ, and cos theta, for theta is equals to 60 degree, therefore cos theta will be equal to 1 by 2. This 2 will cancel out. So, our equation will be 52 is equals to P square plus Q square plus PQ. Now on analyzing these two equations, we can say that PQ will be equal to 12 Newton. Now as we are having two unknowns here, P and Q, and we are having right now only one equation to solve this thing, so we can't get the unique solution of P and Q. For this thing we will have to do some kind of mathematical jugglery. Now let us say we are having value of P, PQ is equals to 12. Now if we say P plus Q whole square, that is equal to P square plus Q square plus 2PQ. Looking to equation number 1, we are having value of P square plus Q square and we are having value of PQ. Now value of P square plus Q square is equals to 40 and the value of PQ is 12. So this would be equal to 2 into 12. So the value would be equal to 64. So P plus Q whole square is equals to 64. Therefore P plus Q will be equal to 8. Similarly, if we write P minus Q whole square, so that would be equal to P square plus Q square minus 2PQ. Now again P square plus Q square is equals to 40 and PQ is equals to 12. So on substituting the values, we are having P square plus Q square is equals to 40 minus 24. So the value will be equal to 16. So we can say that P minus Q is equals to 4. Now we are having again two equations, that is equation number 3 and equation number 4. On solving these two equations, we will have the unique solution of P and Q. So we are having the third equation, that is P plus Q is equals to 8 and P minus Q is equals to 4. So definitely we can get a unique solution, that P will be equal to 6 kilonewton and Q will be equal to 2 kilonewton. Now let us solve the last problem on this topic. Now the problem says that the greatest and least resultant of two forces acting on a body are 35 kilonewton and 5 kilonewton respectively. Determine magnitude of two forces. What would be the angle between these forces if magnitude of resultant is 25 kilonewton. Now this is the data which is given to us. It has been told that the greatest and the least resultant of two forces acting on a body are 35 kilonewton and 5 kilonewton respectively. That means R max is equal to 35 kilonewton and R minimum is equals to 5 kilonewton. And by using these two conditions, we have to find the value of P and Q. So if we apply the two conditions, the two conditions are, we are having the equation R square is equals to P square plus Q square plus 2PQ cos theta, and we also know that for R to be maximum, theta has to be equal to 0. So cos theta becomes 1, right? So for maximum R, cos theta should be maximum, and maximum cos theta maximum is equals to 1 for theta is equals to 0. So if we substitute here, we are having 35 square is equals to p square plus q square plus 2pq. So this is equal to p plus q the whole square. So we can say that p plus q is equals to 35. Similarly, for R minimum, R, cos theta should be minimum, and minimum cos theta is equals to -1 for theta is equals to 180 degree. So if we substitute the values here, so we'll get R is equals to R minimum, R square minimum will be equal to p square plus q square minus 2pq. So that will be equal to R minimum is given as 5. So 5 square will be equal to p minus q whole square. We can say that p minus q is equals to 5. Now p minus q is equals to 5. So on solving equation 1 and 2, let us say this is equation number 2 and the first equation was derived earlier. So we are having two conditions, that is p plus q is equals to 35 and p minus q is equals to 5. So definitely we are having two values, that p is equals to 20 Newton and q is equals to 15 Newton. Now the next part of the question was what would be the angle between these two forces when the resultant is 25 Newton. So on solving, we'll get P is equals to 20 Newton and Q is equals to 15 Newton. So the equation is 25 square is equals to 20 square plus 15 square plus 2 into 20 into 15 cos theta. So 25 square is 625, this one is 400, this one is 225 plus this one is 600 cos theta. So we will be getting 600 cos theta is equal to 0. 600, when the product of two things is equal to 0, then either of two should be equal to 0. Now 600 cannot be equal to 0, so cos theta has to be equal to 0. Now cos theta is equal to 0, that means theta is equal to 90 degree. Now we will be moving to next type of next method to find the resultant. The other method is law of triangle of forces. Law of triangle of forces states that if two forces acting at a point be represented in magnitude and direction by two sides of a triangle taken in order, then the resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. If we see here, then these are the two forces P and Q, and these two forces are represented as the two adjacent sides of the triangle taken in order. Taken in order means head of one force will meet at the tail of the other force. Then the closing side will give the resultant in opposite order. So side R is shown in the figure. Now there is the other method to find the resultant, that is method of resolution of forces. Now resolution of forces, the forces can be converted into or resolved into two components, that is the horizontal component and vertical component. Now if the force as shown in the figure, if we see here, then say any of the force F, it can be resolved into two components. Now let us say this is force F and it is making an angle of theta with horizontal. So the horizontal component will be equal to F cos theta and the vertical component will be equal to F sin theta. Now say there is a force system which is acting. Let us say this is force F1, this force is F2, this force is F3 and this force is F4 force. These are the four forces. The angle made by F2 with horizontal is say theta 2 and the angle made by F3 with respect to vertical is say theta 3 and here the angle made by F4 with respect to horizontal is say theta 4. Now we can resolve all these forces into their components. Now if we see here, as the force F1 is acting in horizontal direction, it won't be having any component in y direction. So the x component of the forces would be F1. Similarly, the other force F2. Now this F2 is making an angle theta 2 with horizontal. So its x component would be having value of F2 cos theta 2 and the vertical component will be having value of F2 sin theta 2. Similarly, this force F3 is making an angle of theta 3 with vertical. So its vertical component will be F3 cos theta 3 and the horizontal component will be F3 sin theta 3. Similarly, this is the fourth force, F4 force, and it is making an angle of theta 4 with horizontal. Therefore its x component will be the cos component and that will be equal to F4 cos theta 4 and the vertical component will be equal to F4 sin theta 4. So the first step will be to resolve the forces into their x component and y components. Now we will have to consider 2 points in this respect. The first point is, if the